different shortcuts that we can prove triangles congruent with, right? So if we think back to section 4.2, where we just introduced congruent triangles, we need to have all three sets of sides shown congruent and all three sets of angles being shown congruent. And we're like, well, that's a lot of work, so let's go through all of our shortcuts. So 4.3, we did just side, 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 which said as long as you have three sets of sides shown congruent between your two triangles, your triangles are congruent. We have side angle side, which says that as long as you have two sides and the included angle shown congruent, then we have enough information to show congruency. Hypotenuse leg is specific to what triangle? A right triangle. So that's an easy one to hopefully recognize. If you see a right triangle, you should be thinking HL right away. Though potentially a right triangle could be side angle side. Okay, so if it's not HL, look for side angle side. And then the last two gets us into, well, what happens when we've got two congruent angles and one congruent side? We have an included side and we have a non-included side. So it works both ways for that. So let's make sure we can recognize where an included side is. So if you have your angles as your lower left, your lower right angles, the included side would be the side that is shared by both those angles. Okay? So let's just do a quick spot check here of included angles. I'm going to make a triangle up here. Make angle 1, angle 2, angle 3, side A, side B, side C. What would be the included side between angle 1 and angle 2? B. Does everybody see that? What would be the included side between angle 2 and 3? C. And the included side between 1 and 3? A. So everybody can see included sides? Yes? Nods of heads? Perfect. All right, so the angle side angle congruence postulate says, and I think I have fill in the blanks here for you guys this round, if two angles and an included side of one triangle are congruent to two sides, or sorry, two angles, not two sides, two angles, my bad, are congruent to two angles and an included side of a second triangle, then the triangles are congruent. So if two angles and an included side of one triangle are congruent to two angles and an included side of a second triangle, then the triangles are congruent. So let's go ahead and sketch that out. What would that look like? So maybe you have this angle congruent to this angle. So top angle to top angle. And then top right angle congruent to the top right angle. So we'll put double arcs in there. So then the included side shown congruent would have to be that top side. So I'm going to put a single tick mark there. So angle, side, angle. The side has to be between the two angles for it to be angle, side, angle. Okay, so let's see if we can recognize the angle, side, angles in these next two examples. So looking at A, do you have two sets of congruent angles? Yep, you got B with M, so if it's helpful, put a little A there, a little A there. You've got C congruent to L, so I'm going to put another A there for congruent angles. And then you got single tick marks for congruent sides. So now you have to decide, is your side included between the two angles? Yes. So this is a yes. Let's write a congruence statement. So I'm going to go triangle A, B, C is congruent to triangle. Looks like A matches up with N, B matches up with M, C matches up with L, and then let's just get in the habit of putting by angle, side, angle. Because once we put it all together, you're going to have to be able to decide which one it is and justify it by writing it. All right, let's look at B. I've got single arc at M, so there's one of my angles. Single arc down there at A. I got a single tick mark, so there's my side. Where's the other set of congruent angles? Jameson? Yeah, the vertical angles right here. We can always add in our vertical angles for congruency because vertical angles will always be congruent. It's the only time you can add in marks are for reflexive property and vertical angles. So yeah, so is your side included between the two angles? Yes, it is. So yes, I'm going to go triangle MNT is congruent to, now in this case, M would match up with A, N with D, and T with T, because they're vertical angles, by angle, side, angle. Okay. Now, unlike side, angle, side, where we are not allowed to have side, side, angle, so here for side, angle, side, our angle had to be the included side. It cannot be the not included side. That's not the case when we have two angles in one side. So we can have the side be included and we can have the side not being included, which gets us into angle, side. So fill in the blanks here. If two angles and the non-included, so if two angles and the non-included side of one triangle are congruent, to two angles and the non-included side of another triangle, then the two triangles are congruent. So what would a non-included side look like? So if I put a single arc at my bottom left angle and a double arc on my top angle, I've got two options of a non-included side. As long as it's not the included side, so either this one or this one, those would be your non-included. So maybe I put it over here. So there would be an angle side. Or it could be down the bottom, which would still also be an angle side. Okay, so we're looking for it to not be included. So let's see if we can see the angle sides in the last two examples here. And then we'll do some practice problems. Very good. Go on the back when you're done. So determine whether the following triangles are congruent due to angle, side. So in this case, I see a right angle. So maybe my first thought should be hypotenuse leg. But notice I don't have any tick marks on my leg, so that's not going to work. So now instead of thinking about it as a right triangle, let's think about my right angles being congruent. So here's an angle congruent to an angle. Here's an angle congruent to an angle. Where's the side that's congruent? Straight down the middle. So is my side between angle?
Yeah.
Well, the included side between these two angles would be down here, wouldn't it?
It has to be the included.
Yeah. So this would be an angle side. So yes, it is congruent. So triangle ABC is congruent to triangle A matches up with D, B with C, C with B, by, this would be angle side. So you got to make sure you can determine the difference between angle side and angle side angle. Does everybody see how B is also the angle side? So it's kind of the same thing. You have your one angle at L and O, the other one at M and N, that angle, and then you have your reflexive property. So yes, triangle LNM is congruent to triangle L matches up with O, N with M, M with N, by angle side. Yes?
Does the order of each parallel matter? Or
Does the order of the letters, you mean?
no, each angle letter.
Here?
Yeah, what if I got
No, it does not matter as long as you have these in the same location.
Okay.
Yeah.
So when would it matter what dead middle, or
No. So to make my life easy grading wise, I usually give you the first three. Like I'll give you this so that there is only one answer for me to grade instead of all different combinations that you could potentially create and then me having to check it. Yeah.
So what really matters is if you get the correct letters on each triangle,
Right.
the different ones.
Yeah.
Okay,
Yeah.
good.
Yeah. Good. Good question. All right. So let's make sure we've got this covered. Do I have any? I feel like I might have a slideshow here. Let's check for a second. Huh? Did I just hear congruent triangles. Here we go. Yeah, go ahead. So side angle sine. Yeah, that's just side angle side hypotenuse leg. All right, so let's see if we can identify different theorems quickly before I give you the worksheet to do. All right, so we got our triangles. What are all the different ways that we could say that these triangles are congruent? Could it be side, side, side? Yes or no?
Yes.
Yes, because you got side up here. Oops, you can't see my mouse moving. You got the side up here with this side. You've got this side with this side, and where's the third side?
No.
Right down the middle. So you got three sets of sides. Could it be side, angle, side? Yes, we've got side, side, angle, side, side, angle, so side, angle, side. Could it be angle, angle, side? Nope. Why not? Because I don't have enough angles, right? Which means I can't have it be angle, side, angle. Can it be hypotenuse leg? Why not? Not a right angle, right? It only works for right triangles. Good. Cadence.
For angle side, even if you did have a good amount of angles, would it matter about the pattern of each, like if one angle is like in one location, but a side was like in the way of the next angle?
So if you had like an angle here, then it could be, I mean, it could work either way, because you could have angle, side, angle right here. Or if you ignored this side and brought in the reflexive property, oops, then it could be angle, angle, side, right? Because then you would have angle, angle, non-included side.
I see.
Okay. All right, let's look at another one. What do we think this one's going to be? Doesn't have tick marks, so it's a little bit trickier. Is it side, side, side? Nope. Because I'm missing a third side. I don't know anything about that. What do I have? I've got a side congruent to a side. Here I've got another side congruent to a side. And what else do I have? I have an angle congruent to an angle. So which theorem is it? Side angle, side. Perfect. All right, let's get that one. What's this one going to be?
Angle, side.
Angle, side, angle. Does everybody see it? Angle, included side, angle. Let's get that one. What about this one? I see a right angle. Is it hypotenuse leg?
Is it
Do I have
angle,
a-
side angle?
It is angle, side, angle. Very good. We don't have a hypotenuse because I just highlighted the hypotenusi in blue. There's nothing given to us there. So I have a side congruent to a side. We have an angle congruent to an angle. And where's the other congruent angles? The vertical, right? So that's an angle, side, angle. Does everybody see it? Does it help highlighting it, or is that a waste of my time? Maybe helpful. What's this one?